All right, folks. So for today's video, what we're going to talk about is page number 89 in simultaneous linear equations, still with two variables. However, this is the special case scenario where we cannot just use a traditional way of elimination. We would have to do some alteration here. By alteration, what I mean is that we have to substitute another variable to this variable. So when we look at this question, the example question, 2 over x plus 1 over y equal to 3, we understand that these are kind of fraction, right? For us to do it, traditionally, what we would do is to multiply both sides by xy to get rid of the denominator and for both equations. So let's try if we are doing that. If I multiply both sides by xy, what I have over here will be 2y plus 2x equal to 3xy. And for the other one, I will have 5y plus x plus 5xy. And you will notice that if I use the new equation number 3 or 4 to subtract or multiply their common denominators, so on and so forth, I would not be able to eliminate everything. And that's the problem over here. We would actually have to be a little bit smarter in this and try another route. So what we do in the equation is that, in the example, sorry, my bad, is that we are substituting 1 over x by a letter a. So we can treat a as, a big X or big Y. We can actually substitute anything. But in this case, the question is using a. And we're substituting 1 over y using the b. So what it does is that when we look at 2 over x, this is actually 2 times 1 over x. So I can actually use 2a to represent that, right? And 1 over y, as the question states that we can use b. So now the equation becomes 2a plus b is equal to 3. And then 5a plus b is equal to 5. And does this look familiar, right? It just looked like that. 2x plus y equal to 3, and 5x plus y is equal to 5. And then you just use your traditional way of eliminating it using equation number 2, subtracting equation number 1 to get rid of y. All right, you get 2 on the other side, 3x is equal to that, so x is equal to 2 over 3. But however, over here, let me just erase all the x because we're not actually using x. And let me eliminate all the y too. We're using a, right? We're using a. And we're using b to represent the y. Okay, so what is a? A, as we kind of talk about over here, a is equal to 1 over x. So which means 1 over x is equal to 2 over 3, and x is equal to 3 over 2. And then you can just substitute that back into the equation and solve for y. So the notion over here is that we're using one variable to represent the other. And at the end of the day, we're kind of solving another equation right there, right? I'm not sure if if I'm explaining that well enough over here. So it's like you are solving multiple variables at the same time, but it's just that one represents the other. You just have to know the relationship and then going backwards. So with that, let's try to do question number 1 here. Okay, so question number 1, we look at the equation. It's 2 over x plus 1 over y equal to 4. 1 over x minus 1 over I is equal to minus 1. Immediately, according to the previous example, what I can do is I can set 1 over x to be a, right? And I can set 1 over y to be b. So when I look at this equation looks like 2 times 1 over x plus 1 over y and equal to 4. So if I'm letting 1 over x to be a, so this becomes 2a plus b equal to 4. That's my equation number 1 now, right? So then for the equation number 2, it becomes just a minus b is equal to minus 1. A minus b equal to minus 1. And then if I add these two together, and you can see that this is actually 1 prime and this is 2 prime. So what we're doing is that we're not really changing a whole lot. We're not changing the equation. The only thing is we're actually substituting 1 over x using a and substituting 1 over y using b. If we add them together over here, right? Because A and B, it's just so easy for me to eliminate it. And then we just solve for A and B for X and Y. So that's the whole notion here. If I add them together, then on the left side will be just 3A. On the right side will be just 3. And A is equal to 1. If A is equal to 1, we know that 1 over X is equal to 1. So X is equal to 1 as well, right? So over here, okay, so which means over here, this is 2 plus B is equal to 4. Then B is equal to 2. So 1 and 2, right? If that's 1 and 2, oh, this 2 is ugly. 1 and 2. So my X is 1 because that's 1 over X is equal to 1. And my Y, all right, because B is equal to 1 over Y. So if B is equal to 2, then Y is equal to 1 over 2. So that's 1 over 2. Let's do another question right here. So let's do question number 3, actually. Let's do a little bit harder one. Okay. So again, I'm letting 1 over X to be, in this case, I want to do X, okay, a big X. And then 1 over Y is equal to a big Y, just so that, you know, we can use different variables to represent different things. Okay, so now, for the first equation, or, you know, equation number 1 prime, we will have X plus Y, which is equal to 7 over 2. And for the next one, I will have X, big X, plus 2 big Y, which is equal to 5. And then what do you want to do now? I want to actually use 2 prime. All right, this is prime. And I want to use 2 prime to subtract 1 prime, which in this case, on the left side, I will get Y, right? What about the right side? On the right side, usually 5 subtracting 3 and 1 over 2, you will get 1 and 1 over 2, which is 3 over 2, right? And we know that Y is equal to 1 over small y is equal to 3 over 2. So Y, little y is equal to 2 over 3, right? We solve for that. However, we still have to use big Y and the 3 over 2 back into the X plus Y. So substitute it into 1. Sub into 1 prime. X plus 3 over 2 is equal to 7 over 2, which means X is equal to 2, right? If X is equal to 2, then 1 over small x, X is equal to 1 over small x is equal to 2, then small x, I should really just use little x like that, all right, is equal to 1 over 2. So now, problem solved, Y is equal to 2 over 3, X is equal to 1 over 2. That's how I solve this question, okay? 1 over 2, 2 over 3. All right, so I want you guys to do question number 2 just in mass exercise. If there's any questions, we can talk about it in the other video. Okay, thank you guys so much.